Hi there, and thank you for joining me today on the Math Social. I just want to remind you guys to subscribe down below so you don't miss any of your favorite math topics. Okay, today we're going to talk all about division with the exponent property. Let's get started. When you do division and you have things with exponents, I actually want you to think more about reducing this. So, if you remember, a cubed is the same as writing a times a times a. So I'm going to write that really quick just so I can show you what's going on. Okay? And then this single a is just the same as 1a. So when we're dividing things with exponents, you really just need to cancel off things that are alike. If we have an a up here and an a down here in the denominator, they cancel each other out like this, and we're left with just two a's, or a squared. So the answer to this problem would be just a squared. Now, technically, we still have a 1 in the denominator, but if you have a 1 down there, that's the same as not writing it at all. This is the most simple way to write it. Let's do another one. This is b to the 4th power divided by b to the 7th power. And as I said earlier, I just want you to kind of think of reducing this instead of dividing it. So I'm going to write this out so you can see exactly what it means. I'm going to write 4 b's being multiplied to each other in the numerator, and then I'm going to write 7 b's multiplied to each other in the denominator. Okay, so if you look at this, these b's would cancel, these b's would cancel, these b's would cancel, and so would these. And we'd be left with 3 b's in the denominator and nothing left in the numerator. It's very important that we don't write 0 in the numerator, because if we ever have 0 in the numerator, that means the answer is 0. So when you don't have anything left in the numerator, you want to write the number 1. The reason is we could technically take what is here in the numerator and multiply all of it by 1, and it wouldn't change anything. So it's kind of like there's an invisible 1 that's always there. So to finish this answer, the best way to write it would be 1 over 1, 2, 3, b cubed, or to the 3rd power. Okay, let's get into some more difficult problems. These ones aren't necessarily more difficult, but they involve numbers. So I could do the same thing I did with the variables, and I could write out 4 3's, and then I could write out 5 3's. And I would see that these would cancel, 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 and I'd be left with 1 3 at the bottom. So the answer to this would be properly written as 1/3. So remember, when you get rid of everything in the numerator, you still have a 1 up there. We don't want to put 0. Remember, that completely changes the answer. So the best answer would be 1/3. Let's try another one. Here's our next example, 4 to the 9th power divided by 4 to the 5th power. So we're going to start moving to doing a little more in our head. So if you can imagine me writing 9 4's out that are all being multiplied to each other in the numerator. And then in the denominator, I would write out 5 4's that are all being multiplied to each other. So think about that just for a minute and figure out how many we could cancel. So it's kind of like thinking the least amount of 4's is what you could cancel, because I would be able to cancel 5 in the denominator and 5 in the numerator, and then I would have 4 left in the numerator. So when you're dividing things with exponents and they have the same base, in our case that's 4, you can kind of take this exponent in the numerator and subtract the exponent in the denominator. So 9 minus 5 would give us 4, and we would be left with 4 to the 4th power. This is one way of writing your answer. You could also figure out what is 4 to the 4th power. What is 4 times 4 times 4 times 4? So if you wanted to figure that out in your calculator, an easy way to do that is to write out 4, and then you want to find the arrow button. It looks like this. That button means to the power of, so I would find that button, and then I would type another 4 representing that 4, and 4 to the 4th power is 256. But like I said earlier, that answer also works. Okay, let's try a problem with both numbers and variables. Here's our next problem, 3x to the 4th power over 6x to the 2nd power, or divided by 6x to the 2nd power. So just to kind of show you what's going on, we have a 3 in our numerator as well as 4 x's. And then in our denominator, we have a 6 and 2 x's. So the first thing I want you to think about is 3 divided by 6. And when we divide numbers like this, you can kind of just reduce it. 3 over 6 is equal to 1/2. 3 goes into 3 once, and 3 goes into 6 twice. So the first part of my answer is going to be 1 over 2. Okay? The second part of my answer, I am going to cancel out some of these x's, and I'm going to notice that I have 2 x's left in the numerator. So remember, you can always take this 4 and subtract this 2 to get 2. So this is one way of writing our answer. Another way would just be to be writing x squared over 2. We don't really need this 1 out there because 1 times x squared is just x squared, and we want to write this as simple as possible. We are going to do 2 more examples, both involving numbers and variables. Here we go. Here is our next example. We have 8x to the 5th power y divided by 10x to the 7th power. So I'm just going to kind of write it how I want you guys to see it in your head. One sec. Okay, so the first thing I want you to do is reduce this 8 over 10. So if you notice, 8 and 10 are both even numbers, so 2 goes into both of those evenly. 2 goes into 8 4 times, and 2 goes into 10 5 times. The next thing that we're going to look at is the x's, and I want you to try and figure out how many would cancel. 1, 2, 3, 4, 5. Now you could do 5 minus 7, which is -2, but we don't really want to write negative exponents, so just a little cheat sheet. If there is a negative exponent in the numerator, it's going to be a positive exponent in the denominator. And I'll get a little more into that when I talk about negative and positive exponents in a different video, okay? So I just want you to notice that there's 2 x's left in the denominator, so I'm going to go down here and write x squared. And then as you can see, that y did not have any other y's to cancel with. There is just one lonely y up there in the numerator, so I'm just going to stick it right back there and it doesn't go anywhere. So this is the best answer to this problem, 4y over 5x squared. Let's do one last problem. Our last problem is 12x squared y to the 5th divided by 6xy to the 5th. So I am going to rewrite this. 1 second. Okay. The first thing I'm going to do is reduce 12 over 6. Now 6 goes into both of those. 6 goes into 12 twice, and 6 goes into itself once. Okay? The next thing I'm going to do is cancel out as many x's as I can, and I see that I canceled out all of them in the denominator, and I still have 1 left in the numerator. So there's that x. And now I'm going to cancel out as many y's as I can. 1, 2, 3, 4, 5. You could also see that by going 5 minus 5, which would give you 0 y's left. So I'm not even going to write it. 2x over 1 is the answer, and the best way to write that would just be 2x. Now, you could have written y to the 0 power, but y to the 0 power just actually means 1. So that means 2x times 1, which is just 2x. So if you ever have that written to the 0 power and you're multiplying, you really don't need to write it at all. So I hope that helps. I will make another video talking about the negative exponents, and we'll go a little bit deeper into that. But if this made sense, don't forget to give me a thumbs up and subscribe below.